Okay, now you're on video. Measurements. Why do we measure stuff?
It's fun.
To know how long they are? Because it's fun. You know what the real answer is? The real answer is taxes. That's why we measure stuff, yeah. Measurements started in a dank river valley called the Nile. And in Egypt, yeah. So we had all these, because before then people had been just chasing around their food, you know, running and catching things, and right? And then somebody was like, forget about this. Let's just plant some grass and see if we can eat that. And so then you got all these settlements and people and business and trade and all this and government and pharaohs and society, you know. And the pharaoh needed to collect taxes, but he could not collect the same amount of tax from every person. Why? Not everybody has the same size farm, right? So if you take too much tax from the person with a small farm, they'll starve and die, and then you have no more farm tax coming in. And the big guy, you want to tax them more because they have more, bigger harvest, right? So how would you measure a farm?
Area.
Yeah, area is a good idea, Costa. So how would you, if you're early human for society, we don't know centimeters or meters or anything like that. How would you measure area?
By cow.
By cow? Number of cows? Yeah, if we had cows, that would work. I don't think they had cows then yet.
It's my strength.
Ty.
Nowadays, if I don't have anything on me, I just use my foot. This
Well,
many feet long.
that's absolutely right. So a tax collector would come to the field and they would just step the field, right? 1, 2, 3, 4, 5. And so if I did that, I might count 40 steps, but if Jeffrey Jackson did that because he's tall, he might count 20 steps, right? So we needed something called a referent, and Ty's absolutely right. We used a foot, and we started with this tax collector's feet, and then of course that tax collector's feet have different size feet. And so whose foot did we use?
We use
The Pharaoh's foot. The Pharaoh's foot was the first foot. And then it became the King of England and all these other people, right? Hold up your thumb. The width of your thumb is an inch. Well, the width of the king's thumb was the inch. And so we used feet and inches. Has anybody here built something in feet and inches? Yeah, it's annoying, isn't it? Why is it annoying, Gordon?
It's hard to make it like precise and measure what we actually need. For centimeter, we can go over to millimeter and then do it better for measurement.
Yeah, exactly. So meters and centimeters are all base 10, right? Whereas you gotta have 37 and 11 30-seconds if you want to get, you have to go smaller and smaller fractions with inches, right? So there were some French people that decided we don't like all these fractions and measurements, let's come up with something that's more sensical. So they came up with, they based all our measurement system on something else. Is it Ella? Could you open the door for McKenna? Thank you. What are our measurements today based on? Do you know? What did you say, Dylan? It's definitely base 10, yeah. But what do we use instead of the foot? We need some kind of referent, right? Say it again. Oh, meters, yeah, sure. But where does a meter come from? The wingspan of something? Yeah, that's a good guess. That's a good guess. The group of French people who came up with this. No, but a baguette would have been perfect. It would have been perfect. Water. We used water because we realized, we thought, well, if you don't have access to water, you're not going to be alive long anyway. So everybody needs access to water, and so we can use that for our measurement. If you were to make a cube of water, just hold your hand like this. That's about 10 centimeters, yeah? So if you make a cube this wide, this deep, and that high, all 10 centimeters, how much water is it? Say that one more time. It's not a meter squared, but you're on the right track. All right, this is volume now, right? So is it centimeters squared or cubed, Costa? Cubed, good. So these are cubic centimeters. How many cubic centimeters is it? 1,000, right? 10 times 10 is 100 times 10 is 1,000. So this is 1,000 cubic centimeters, which is exactly 1,000 milliliters. 1 cubic centimeter is 1 milliliter, which equals how many liters? 1 liter. This cube is exactly 1 liter, and that's where we get the volume liter from. How much does it weigh? Well, oh, sorry, I should say, what is its mass? Its weight is a little bit different, but what's the mass of this cube of water? What would you guess? Brigitte? Very good. Very good. This is 1 kilogram, and that's where this mass comes from. This cube of water weighs exactly 1 kilogram, which is 1,000 what? Grams. Good. You have 1,000 grams. So one cubic centimeter, what would that weigh? Or what would its mass be?
Would be 1 gram.
1 gram. 1 gram. So it's very nicely broken into, these little pieces. 1 little cubic centimeter is exactly 1 milliliter and weighs 1 gram. Its mass is 1 gram. And you times that by 1,000, you get 1,000 milliliters in 1 liter. If you put a flame underneath this cube and you put exactly 1 calorie of energy into it, it's actually a kilocalorie. It's a little trick. If it has a capital C, it's actually a kilocalorie. That will raise the water's temperature by 1 degree Celsius. So that's where degrees come from, and energy, calories, volume, milliliters, liters, length, centimeters, and mass in kilograms and grams. All comes from water. Have you heard the term SI units?
Yeah.
You know what it stands for?
No.
International systems.
Very good, yeah. Système International. Say it with me.
Système International.
Why is it French?
Because the French people made it.
Because the French people made it, right? So we have them to thank for metric. If you've heard of metric, that's SI. That's the French system. And it makes a lot of sense. It's kind of nice. By the way, you know how the United States still uses feet and inches?
Yeah. Why?
What do you think they base the foot off of?
Washington's French.
No, they base it off of this.
What?
Now, the exact foot is an exact ratio of 1 meter. Before the meters, it was never exact. It's really interesting. So the United States is actually metric, even though they still say they're not.
So why did they say
I don't
that?
understand. Could you repeat that, please?
Pardon me?
Could you repeat that, please? I don't understand.
Yeah, so if you go to the United States and you want to get something done in feet, and there's been lots of mistakes because of this system. The foot, the actual precise unit of the foot, is based off of it's a specific percentage of 1 meter. Because we maintain all these, like if you want to be like super precise, these are maintained in the SI system. Many of them are maintained in the US as well, like the kilogram, for example. And as things get more and more precise, we need more and more exact definitions. Length. What is the unit of length?
Meters.
Is meter spelled E-R or R-E?
That's what we split in Turkey, but
Last class I did it RE, so with you guys I'll do it ER. I don't know what's right actually. I think it's a British American thing, but so meter, symbol M, right? The simplest. What about mass? Good guess, that's all. It's actually the kilogram. And this is the only SI unit that has the prefix there. It's the only one. So you have to kind of remember if you're doing physics and you need a measurement of mass for all these formulas and everything, anywhere you see an M, that's going to be in units of kilograms. Okay. What about time?
Seconds.
Seconds. So the second is the unit of time in S. Speed. Kilometers per hour is what you find in your car, right? But Ty? Meters per second is what we use in physics. I'm just going to put the M for S. You guys know what that means. What about acceleration? Just pull one from the back there. Look.
M over S squared.
Say it one more time.
M over S squared.
Yeah, so we should talk about this just a little bit. We're going to learn all about this, but what is acceleration?
The rate something speeds up.
Interesting. Okay, yeah, the rate something speeding up, and Ty goes like this. Yeah, so your speed is getting faster and faster. And so it's, we use this unit, Jeffrey Jackson has said meters per second squared, and he is correct about that. This is really meters per second. So if you get in the car with mom or dad and you're on your way to school and you're late, hits the gas, right? And you're speeding up, you get faster and faster. If you're accelerating at, say, 3 meters per second squared, that means every second you're getting 3 meters per second faster. Would it be okay to say meters per second per hour? Would that be like a valid unit of acceleration?
Meters per hour would be.
What about meters per second per hour? Would it work?
Why?
Yeah, it would be fine. It would be fine. If you had an acceleration of 40 meters per second per hour, that would mean every hour you're going 40 meters per second faster. Now, our SI unit happens to be meters per second, and that's why we can just square this one. Okay. What about force? Newtons, yes, good, newtons. We'll use the capital N for that. And the symbol is a big capital N. That's named after Isaac, of course, and we're going to learn a lot about that. What about energy, time?
Joules.
Joule, good, the joule. But not like the jewels in the crown. It's a different kind of joule, and to finish our semester we'll learn a bunch about energy and joules. Okay, good. I'm going to post this on the classroom so you can refer back to this. I'm going to erase all my writing here. Now, of course, it's not just as simple as knowing all the units. All those units have prefixes, right? So we have all these prefixes. Who has heard of mega? Good. You've probably heard of megabytes, right? So what does mega mean?
Really big.
Say that again, Dylan?
Really big.
Really big, yeah, for sure. How big?
No.
100 million. 1 million tons.
10 times 6 more, yeah. What is 10 times 6?
1 million.
Or 10 to the power of 6. Yeah, this is a million. So, if you have a million bytes, that's a megabyte. If you have a million grams, that's a megagram. If your power station produces a million watts, that's a megawatt. Okay. That, I would say, you should know, for sure. Memorize that one. Kilo, you should know. What is kilo? 1,000. So there's 1,000 meters in a kilometer, right? Kilometer, and that's 10 to the 3. This one, hecto, you don't see that one very often. It's kind of just doesn't get used very much. It's the 100. Now, if hecto is 100, how come we call it a centimeter? Isn't there 100 centimeters in a meter?
Those times.
McKenna? She's just pointing. What, this one? Why is it down here and not up here? So is a centimeter bigger than a meter or smaller? Smaller, right? So that's why it's down here. So the centi we want to remember. Hecto's kind of like, I would tell you if that was a hectometer. Deca you don't see. Deci you see from time to time, like a decimeter. That cube that I drew is actually a cubic decimeter, right? 10 centimeters. And this is 1/10. But I wouldn't say memorize that, but you should memorize mega and kilo and centi and milli and micro. Milli is 1,000th. What is micro? A millionth, right? 1 millionth. It's shown by a symbol like this. This is not an M, it's not a U, it's a mu. This is a Greek letter. Everybody say mu. It's nice. And this is like 1 million. It's what my cat says to me every day. Yes?
Do we need to know nanometers?
Yeah, we can get smaller than micro. So Jeffrey, what's next?
Nano.
So you can have nano as well. This is 10 to the negative 9. So this is 10 to the negative 3, right? Sorry, 10 to the negative 6. So micro, and this is micro by the way, 10 to the negative 6, and nano's 10 to the negative 9, and then if you get even smaller, Ty?
Pico.
Pico.
What's the symbol for nano?
Nano is N, and pico is P. So if you see, for example, 400 nm, what does that mean? This is 400 nanometers. So this is the wavelength of which color light?
Oh.
Anybody know?
Is it infrared?
No, it's an invisible
Is it the shortest one or the longest one? It's the shorter one.
Violet.
Yes, blue. Yeah. Well, violet. You could say violet too. They took violet out of there. You know? Oh no, no, not the violet. They took the indigo out.
What's the factor for pico then?
Pardon me?
What's the factor for pico?
The factor for pico is 10 to the negative 12. So micro is a millionth, nano is a billionth, and a pico is a trillionth. And smaller than that you don't have to worry about. But it's very, very small.
Yeah, I was gonna. Which ones should
It'll be on the video. Is the video still showing all this?
Yeah.
Okay. Let's carry on. So, who knows how to convert units? Who's never done this before? Okay. Who's like, yeah, I remember it, but I need a review. Okay, good. Let's do it. There are 2 ways that I'm going to show you to convert units. I don't mind which way you use, or if you have a different way that you would like to convert units, it's totally fine. So long as you have a method that works for you and works all the time, then it's fine. This is the kind of mathy way of doing this. So if you have a mathy brain, you're going to say, okay, I'm going to take my known multiple factor. So like if it's, well, let's do an example. Give me a unit. Picometers, okay. Give me a number.
20 picometers.
Okay, we're gonna do 20 picometers.
2 megameters.
Oh. All right. And remember, if you see mm, the big M and little m makes a difference, right? So little m is millimeter, but what does this mean? This is megameters, right? Okay, so who knows the power of 10 for pico? This is negative 12, and mega is 10 to the 6. Okay, so we know the picometers. So what this is telling you here is you say known multiple factor minus the unknown multiple factor. So we know negative 12, so we're going to go negative 12 minus positive 6. What does that give us?
I think it's
Negative 18. And so we're just going to take our 20 and we're going to go times 10 to the 18. And that will be in megameters. Okay, so that's really all the math you have to do. This is the correct number. Is it in scientific notation?
no.
No. So we really want to put this decimal
It should be negative 18.
right after the 2, right? Oh, sorry, this has to be negative, yeah. Cool. That would be a really long distance. When you leave the minus sign off of this, it really makes a really big difference. Yes, 20 times 10 to the negative 18 megameters. So 2.0. And if you're making this number smaller, you have to make the power bigger. And so to make this bigger, think of this as 18. Negative 18 is 18 underwater. So to get bigger, I need to go up, right? And so this is going to be 10 to the what? Negative 17 megameters. So this would be the correct answer in scientific notation. Does that make sense? Kind of, sort of? Okay. Yeah, feel free to take a picture if you want. And I will post this video. Okay, there's another way to do this, and I'm going to show you. Can they see over here on this board? On the phone? Or do I need
They can see. They can
Barely.
Just like stay like on that side.
like over here?
So
Yeah.
right now, we can't see, but we can see your hands. And now we can see.
Okay. Let's do this a different way. I'm just going to get a pen here.
Can you just switch the board? Like this?
I can switch the boards, but not the projector. Let me grab a blackboard. But I can turn my phone. Some of you, this is going to be, for whatever reason, is not going to be intuitive, but some of you will use this kind of table method. So you do a chart like this. Who knows that way? Okay, and this is fine. You can do this too. So this is picometer. If you know what a picometer is, you can put the picometer on the bottom and you can convert to meter first. So if you know, okay, there's 10 to the 12, if you know there's a trillion picometers in a meter, you would say 10 to the 12 in 1 meter. And then you would say, okay, that gives me meters, because I'm going to cancel out these picometers, but I want to get to megameters, so I'm going to say megameters, and there's 1 million meters in a megameter. So you're dividing by 10 to the 12, and then dividing by 10 to the 6, and you cancel out these units, and then you end up with the unit that you want. And so, of course, when you divide by these numbers, it comes out to the same answer. Okay. If it gets into these kind of factors, like the 10 to the 12 and 10 to the 6, it's a little bit, it's less simple, right? But when you're doing like,
You first convert to meter?
you can, yeah. Yeah, you can do it in 2 steps. That's totally
Is
fine.
that what you did?
That's what I did here, yeah. So I just happen to know that there's 10 to the 12 picometers in 1 meter. Let's do a simpler example. It might be easier.
So then,
How do you know what to subtract or add?
Mila, give me a number.
Like the ones that you're talking about, like the negative
Like a
12 is
unit or
6.
Just a number.
6.
Okay, so let's go 6 centimeters, and let's do it to kilometers, okay? So you guys tell me how to do this. You're doing the chart way.
So it's gonna be
And 1 kilometer.
10 to the 2 over
6
divided by
million
10 to the
Let's convert it to meters first.
times 10.6.
How many centimeters are in a meter? 100, you know that, right? So you're gonna put 100 here. And then,
There's 1,000 meter and 2,000
It's just
Mila, what would I do next?
I have no idea.
Okay, I'm trying to get to
So it's
kilometers.
gonna be like
So I'm gonna put kilometers here.
so the rate 1,000.
So I did this because I can cancel out my centimeters, right?
So you put whatever you're trying to find on the top.
That's right. And whatever you had, you want to get rid of. So what am I putting down here?
meter.
Meter.
Meters, good. Because then this is going to cancel out, right? And I'll be left with kilometers, but I need to know how many meters in a kilometer.
1,000.
One. So if I just take my 6 and I divide by 100 and I divide by 1,000, you can do this with powers if that works well for you, but if you're a little bit intimidated by the powers, you just know this is 5 zeros. So you're gonna take your decimal and move it back 5. Now, this is weird because there's no decimal here, right? Where's the decimal? It's always here. So if you don't see a decimal, it's always at the end. So I want to move this back 5 spaces. So I go 1, 2, 3, 4, 5. And I have to fill that with the zeros. So this is going to equal 0.00006 kilometers. Yeah, and if you were going to do this in powers, you would say that's 6 times 10 to the negative 5 kilometers. So 6 centimeters is 0.00006 kilometers, or 6 times 10 to the negative 5 kilometers. Okay. Either way is fine, and you can use both if both of them make sense to you. Okay.
For the one before, why do you like subtract it? Like the power.
Why do you?
Why did you subtract the power? I
Um,
don't know.
why do you subtract the powers?
Oh, it's because you're canceling them out, right?
Yeah, I guess because you're taking what you know and trying to go to a different unit. And so you have to start with the exponent that you actually have in your unit, and then subtract away the one that you're trying to get to. It's kind of weird mind thing. Dylan, you go ahead, try it.
Find what you need to get there.
Yeah, that's right. So like, if you think of centimeters as being smaller than a meter, think of like a meter as the surface of the water. A centimeter is 100 down, right? So you have to go from here at 10 to the negative 2, and you have to go up 2, and then to get to kilometers, you have to go up 3 more, right? So it's kind of like, how far did you have to go to get from here to here? So you subtract them, and that gives you the distance. Does that make sense, kind of? It's a bit weird.
Not really, but like,
It's a little bit backwards because what you're actually doing is keeping the value exactly the same. You're just changing the unit, right? But it works,
It's
so.
because the factor and the amount you have is like the opposite. 1 kilometer has 1,000 meters in it, but it is, so going down 2 kilometers would be 10 to the power 3. Going up would be 10 to the power negative 3. because
Yeah, yeah.
1 is 1 divided by 1,000.
Yeah, so like where if you start 2 down, but you want to put this unit, you actually have to start up here and go, how far down do I have to get to make that into this unit? It's interesting. Okay, Try these 3 examples, and I'll come around and check those. If you're watching the video, pause the video and try to do these on your own. And I'll just write them.
Subscribe and
Don't resist it. What's that?
don't forget to like, subscribe, and
Yeah, don't forget to hit the like button and all that. My next session is with Mr. Beast, and I'm gonna be
oh my god.
I'm gonna be opening some presents in like a 12-foot bowl of cereal. Do you know that's how they make all the money, right?
I have no idea.
The most profitable YouTubers are all kids who open like
Oh, yeah.
presents.
Oh, yeah.
Yeah.
They make like $20 million a year.
Really?
Yeah.
Maybe
I'm
the
teaching
same-
quantum mechanics, and they're like getting rich on opening presents. It's interesting. I'm just gonna write this down. Yeah, Emin? Oh yeah, tell me.
1.68 multiply 10 power minus
From here?
yeah.
Okay, so we're going. Do you want to do the chart way or the other way? You want the powers way? Okay, so this is 10 to the -3, right? What if it's just meters? Do you have to subtract anything? No, it's just 0, right? So this is just 0, and you do -3 minus 0 is just -3, and so this is 165 times 10 to the -3. If you're doing it the chart way, you want to get to meters. How many millimeters in a meter? 1,000, right? And 1. So either way, you can either come from the powers way, or you can come from the chart way, and you're going to end up with 0.165 meters.
Did you not go to centimeters first and then centimeters?
Yeah, that's what I did.
Oh, you could.
Would it be like?
But there's,
But then you divide.
oh, so you know that there's 10 millimeters in a centimeter? If you were gonna do it that way, I would suggest you know that there's 1,000 millimeters in a meter. But if you were gonna do it through centimeters, you could do that. You would say 165 millimeters. And then if you said, okay, I know that there's, 10 millimeters in 1 centimeter, you could do that, and then go to meters, and there's 100 centimeters in 1 meter, right? It'll come out to the same thing.
Yeah.
Some of you are looking at this and you just kind of know that a millimeter is 1,000, there's 1,000 in a meter, so you just go 1, 2, 3, and that's totally fine. If you do this a bunch of times, you'll get used to it, and you'll just remember, oh, if it's millimeters, I gotta go back 3.
Would you write it as?
Give me 1 second, sir.
Write 1.65 multiply 10 power minus 1.
Yeah, so if you want to put this in scientific notation, we actually can't leave it like this, right? So we're going to say really 1.65. I'm making this smaller by 2, right? So this has to be 10 to the -1. Yeah, that's right. And this would be meters, right? So this would be kind of the correct scientific notation number.
Why is
Most of the time we don't bother with that. If we're just turning this into meters, we just put the decimal because it's pretty close.
why meter 0?
Because meters has no prefix.
Okay.
It's the actual unit that all the prefixes come from. What's CG? Centigram. So this is 10 to the -2, and m is 10 to the -3. So we're doing -2 minus -3, which makes what?
1.
1. So you do -2 minus -3, which equals positive 1. So this is 380 times what? 10 to the power of 1, which is just 10. So you could probably just leave this at 3,800 milligrams. You could put it into scientific notation too if you wanted to. You could say 3.8 times 10 to the 3 if you wanted to be right on your sig figs. How many people got 3,800 or 3,800? Okay, good. What's the capital ML? Megaliters to milliliters. That's 10 to the 6, and this is 10 to the negative 3. So this is 6 minus negative 3. So we get a 9. And so this is going to be 24 times 10 to the power of 9. And really, technically, we should say 2.4. And we're making this smaller.
10 to the power of 10.
That's right. That has to be bigger. So this is going to be 10 to the power of 10, and this is milliliters, a lot of milliliters.
So is it always gonna be like subtract, the subtraction?
You always take the one you know, and you subtract the one you're trying to get to.
So we always subtract?
Always.
Okay.
Yeah.
I just want to know how you got 3,800 milligrams from the scientific calculation.
From this one?
Yeah.
Oh, okay. Yeah, so just going from here to there. So, well, really this is just 10 to the 1 is just 10, right? So I just add a 0 to it.
Okay.
That's all. If I wanted to take this and put it into scientific notation, sorry, I got a lot of arrows going on here. I would do 3.8, and I would multiply it by 10 to what power? That's right, 3. Yeah. And that would actually be correct in scientific notation. Yeah. And that it's still milligrams. So sometimes I'm going to ask you, or you're going to want to put it in scientific notation, and sometimes it's fine to just keep it a number. It kind of depends on what you're doing and where you're going with that. How many people got those all right? Good. Who's feeling like, yeah, this scientific notation, I got this, is fine. Actually, hold your hand in front of your nose right now. Okay? Just for a second, I'm going to ask you to close your eyes. If you're feeling like, I'm super good with this, we can like totally move on, then you're going to put it up above your forehead. If you're thinking, I'm struggling a little bit, you're going to put it down a little bit, okay? Close your eyes in 3, 2, 1, go. Put it up or down. Okay, good. Put your hands down and open your eyes. Okay, that's fine. Good, thank you. Now, I'm going to give you this. It's a little bit of scientific notation, and on the back, I'm sorry, it's significant figures. I don't need you to super focus on the sig figs, but you should know it, and if you want a little review, you can do that. I'm going to give you this to work on, so you have a little bit of time now, and I will check your problems from the red textbook as well.